So, what I'm going to talk about today is the whole problem of how do you get visibility and assure and secure services in a 5G network. This is what Netscout does as its core business, and as you all know, 5G introduces a lot of new components, new architecture, new way of designing things, and all of that creates uncertainty around how are you going to monitor and measure services. And the risk here is if you don't do it right, then obviously you are risking your customer experience, which you really don't want to do if you want to retain and grow your subscriber base. So we feel that this is an important area where careful thought has to be put in to see how you want to monitor, assure, and secure your services. So let me start with that to talk about the challenges. As I said, 5G presents it's quite a new architecture in several dimensions. And to start with, on the radio side, because of the use of higher frequency bands, the RAN network becomes denser because of the shorter range. And also in these higher frequencies, delivering consistent service quality is challenging because there are susceptibilities to environmental conditions, building attenuation, and so on. And furthermore, if you're going to roll industrial applications, which we believe is a main driver, then they will demand more committed levels of service. If you look inside the core, then we see a lot of disaggregation and distribution going on. Not only the RAN gets distributed in a cloud sense between the baseband unit and the radio unit, you also see control and user plane separation. You see something called network slicing, which is a feature that allows you to virtually carve up your network to deliver different rates of service. And also you see the introduction of an edge cloud, which is where the user plane will reside in many cases. And how do you look at your data sources from different places and correlate them to give an accurate service level view is a new challenge that wasn't there in 4G because that was a very centralized architecture. Third point clearly is what Red Hat mentioned was cloud native implementation. I think for the first time you see in a major 5G network the introduction of virtualization and cloud native technologies using containers and virtual machines and a combination of those. There is going to be increasing reliance on open source software, as we heard from the Red Hat gentleman. And because of the new architecture and new software supply chain that is going to be deployed, there will be new security vulnerabilities and visibility challenges in these architectures. So the bottom line is, how do you secure and assure services in such a dynamic and complex environment? So let's take that problem statement and talk about it. So as I mentioned, in terms of the main drivers, I think what we are seeing in the industry is that the enterprise and industry verticals will drive 5G, at least initially. Because on the consumer side, there is not a whole lot of excitement to use just the smartphone. So until some new devices show up, like AR, VR, and so on, I think for operators to grow the top line, they will be looking to expand into the enterprise sector, especially where there is a lot of demand for enterprise IoT. Utilities, manufacturing, transportation, e-health, agriculture, smart city, all of these, either they have a low latency requirement or they have a high availability requirement, or in some cases, if you're using video to transport information, that's going to require higher bandwidth. And each of these verticals will run in a dedicated slice because to offer different grades of service to different industry verticals, you have to use this network slicing feature, and then you have to assure that these SLAs are being met within each slice. So this is going to be the key to the success of enterprise IoT is how well the operators are able to provide SLAs and enforce them and make sure that the customers are getting the performance that they need for their applications. So let's talk about the edge, because we feel the edge is the new place where a lot of the services will get deployed. As you know, it's going to be built on a microservices architecture. It's what we call the edge as a micro data center. It's a mini data center that can reside right next to the RAN or a little bit deeper into the network. But the bottom line is it's much closer to the end user. But because it's an edge with limited resources and constrained environment, the footprint of how much horsepower you can put there will be very limited. And that's the reason why you have to be extremely efficient in using a container type environment and distributing the user plane functionality. You may also need some of the applications to be hosted right there, especially if they require low latency. And of course, in an edge, when you're deploying them in hundreds of different locations, automation is going to be key. Otherwise, you're not going to be able to manage such a large deployment of edge data centers. And of course, security becomes very critical because these are environments which are not as secure as your core data centers are. And you have to be very careful in detecting attacks and be able to mitigate them very quickly. So the three things I mentioned here: ultra low latency, high bandwidth, and giving the assurance from a service and security point of view. Some of the examples that we have seen are, in the CV2X protocols, which is about vehicles, autonomous vehicles, connected cars. You really require 10 millisecond or less latency, 4 nines availability because these are mission critical. They can impact lives. E-health, remote diagnosis, patient monitoring, they are also time-sensitive services. On the bandwidth side, especially when you're doing fixed broadband, you're looking to deliver ultra-high definition video, and you need to be able to buffer content there like a small CDN to be able to give the right levels of service, and also to reduce backhaul cost. And for all of these applications, the application layer visibility is key. It's not enough to monitor your infrastructure in terms of CPU usage and memory and so on, but you actually have to look at the flows on your service and application layer because that's where the latency and the throughput guarantees have to be enforced. And to do that, you really need a predictive environment where you can avoid the problem and through automation be able to take corrective action before they become impacting to your service. From a challenges point of view, I'll quickly mention 3 areas. You really need to be able to provide pervasive visibility because of a distributed environment, all the way from RAN to the edge to the core. So you need a monitoring of different footprints, lightweight all the way going down to the edge, and high throughput, high measurement processing in the core. So you need flexible instrumentation. You need to be able to do assurance and automation in real time. So there has to be a way to stream these KPIs in real time into an automation platform so actions can be taken in a timely fashion. And from a security point of view, I think the most critical aspect is you don't want these attacks, the persistent threats, to proliferate in your environment and create a havoc. You want to be able to have early warning indicators, early detection, so you can catch them and stop these before they become detrimental to your network. So all of these can be done using technology that we provide. So from a Netscout point of view, we have a technology that looks at network data, which we call smart data. It's looking at wire data, which is your network packets, and be able to extract your service layer metadata in real time, which is the real intelligence. And we do this in a vendor-independent way, and we can do it in a universally available fashion across your entire infrastructure. The technology works cross-domain. In other words, you can look at the service across any cloud infrastructure, whether it's VM-based or container-based, any network, any cloud, any workload, and be it pervasive and end-to-end. So which is very critical if you have a distributed mesh network between the edge and the core, your control plane is being serviced in the core, your user plane is at the edge. We need to be able to put it all together in a consistent fashion. Our solutions work across traditional IP services. We have also implemented capabilities for monitoring IoT devices and IoT sessions, and we provide full workflows for service assurance, security assurance, and customer experience. There are 2 components to a solution. There is a visibility part, which is what sits in the infrastructure looking at network traffic, and we provide service layer metadata right at the source of where the packets are, both for the control and user plane. Highly optimized cloud native implementation, so we can do this using as few resources as possible, running in both VM and container environment, public and private cloud, and more importantly, everything can be orchestrated from a central automation platform. The analytics side, which is what we use our nGenius brand and our Arbor brand, it is for providing consistent workflows across end-to-end service correlation, SLA management, subscriber analytics, threat analytics, and also exporting our data to closed-loop automation platform for making corrective actions. So I'll just end with this. One more slide before I end. So here I'm showing an end-to-end 5G network all the way from edge to the core. So the instrumentation is deployed in either container format or VMs across this distributed cloud architecture, and all the data in a unified data model is brought up to the nGenius platform for doing your end-to-end correlation across this multi-cloud environment in 5G. To conclude, what we are seeing in the industry is that service providers are deploying 5G and edge cloud to deliver new services with speed and agility. That seems to be the name of the game, especially the way the environment has changed. Everything is being offered as a service, so the speed and agility is very key. And our solution is uniquely positioned to help customers migrate to 5G in a non-disruptive fashion. Because one thing you want to make sure is, as you are moving to a new solution, you still have your services running on your 4G network, and you want to be able to make sure that your services are not negatively impacted. So our solution based on wire data, cloud native, reduces the barrier to implementation from a cost point of view, real-time metadata used on multi-cloud platforms, and all the use cases around service security and customer experience. All of them come together to help our customers navigate this difficult environment.